Hello, this is Miss Moore, and today we're going to continue our discussion on atoms. Specifically, we're going to be talking about atomic number and atomic mass. Today's essential question: what can the atomic number and atomic mass tell us about an atom? All right, we are going to just start our discussion with the atomic number. But before we can do that, we need to do a little bit of review on protons and electrons. Remember, two of the three subatomic particles. So protons are positive. Remember, P plus. And if you remember, protons live in the nucleus. So if protons are positive, that means that the nucleus is also positive. Okay. And electrons are negative, E minus, and electrons live in the electron cloud, which means the electron cloud is negative. So then we also have the neutrons, right? The neutrons are neutral. I'll just stick them right here. And so we're not really going to talk about the neutrons right now because the atomic number and our discussion has to do with charges. So even though the neutrons are part of the subatomic particles, we're going to ignore them for the moment. Okay, so onward. Here's the big deal. Atoms are neutral. They have no charge. So atoms are made up of something that's positively charged, negatively charged, and neutral. So how in the world do we end up with an atom that has no charge? Think about that for a minute and see if you can come up with the answer in your own head before I proceed. All right, anyone come up with anything? Well, the way this works is that if an atom has the same number of protons and electrons, their charges cancel out. And if the charges cancel out, the atom will be neutral. Okay, let's proceed. So we have this thing called the atomic number. And the atomic number is the number of protons. And furthermore, because the atom is neutral, we just talked about this, but the number of electrons will also be the same as the atomic number. However, the definition of the atomic number is the number of protons. This is really, really important because you're going to find out later that the number of electrons can change, but the number of protons cannot. Neither can the atomic number. So, the atomic number is the number of protons. That means, and because an atom is neutral, the way you can think about it is that the number of protons equals the number of electrons. But the definition of the atomic number is the number of protons. Okay? Another really important point. All atoms of the same element will have the same atomic number, which means that it is the number of protons that define what element an atom is. Okay, so the atomic number is the number of protons. The number of protons also equals the number of electrons. And it's the number of protons that define what type of atom it is. So all atoms of the same element will have the exact same atomic number. So we're finally getting to use our periodic table. So I've uploaded here just a small portion of the periodic table. But the atomic number can be found on the periodic table, which is really cool because by looking on the periodic table, we can find the atomic number, which means we can also find the number of protons for each atom. So if you look at the key right there, you'll see that in this particular periodic table, the atomic number is written on top in the middle. By the way, whenever you look at a different periodic table, always start by looking at the key because not all periodic tables are organized the same. Okay, so if we start by hydrogen, hydrogen has an atomic number of 1. So how many protons does hydrogen have? 1. And how many electrons? Also 1. Let's pick a different one. How about, let's try scandium right here. So scandium, its atomic number is 21, which means it has 21 protons and 21 electrons. Okay, so and you can do that with every atom, every type of element on the periodic table. So iron has an atomic number of 26, which means 26 protons and 26 electrons. Another way you can look at that is if I said, hey guys, what atom has 19 protons? Well, you know if it has 19 protons, its atomic number must be 19. So what atom is that? That would be potassium. All right, so that is how you find the atomic number on the periodic table. And again, the atomic number equals the number of protons. That's the definition of the atomic number. And the number of protons equals the number of electrons so that the atom is neutral. All right, before we move away from the periodic table, I wanted to show you, back on the key, the element symbol is a series, it's a letter or 2 letters. Okay, you'll note that if there's only 1 letter, it's a capital. So hydrogen, potassium, deuterium, vanadium. Okay, so the atomic symbol for hydrogen is a capital H. The atomic symbol for potassium is a capital K, etc. If the symbol has 2 letters, the first letter will be capitalized and the second letter will be lowercase, and that's going to be important later on. But for example, chromium is capital C, lowercase r. Magnesium is capital M, lowercase g. All right, onward. We can write the symbol of an atom. So if we're going to be talking about, we'll start with carbon. That's a nice easy one. If I were to write the atomic symbol for carbon, let's go back and look. Carbon is not on here. Okay, well, look on your periodic table. You'll find it towards the right, towards the top on the right. You'll see that the atomic symbol for carbon is a C. Okay, and usually when I ask you to write carbon, you just write it with the C. But sometimes you're going to write something called a nuclear symbol, and I'll label that in a minute. And if you do that, you're going to be writing the atomic number with the element symbol. So it's going to look something like this. Here is the element symbol carbon, right? And then before it, but as a subscript, you're going to write the atomic number. And that's actually pretty cool because we also know if that's the atomic number, just by looking at that, not even looking at the periodic table, we know that it has 6 protons. And if we know if it has 6 protons, we also know it has 6 electrons. Okay. All right, let's change gears now and let's discuss the mass number. So the mass number, also known as the atomic mass, is the number of protons plus the number of neutrons. So what I'm saying here is that you can know the mass, or the weight if you prefer, of an atom based on how many protons or neutrons, which seems a little weird, but remember, hopefully, that proton's mass is 1 AMU. Neutron mass is 1 AMU, and electron's mass is basically 0. So if we know we have 5 protons and 5 neutrons, just add that all up, what do we get? We get a mass of 10, right? So we have a little equation here. Mass equals number of protons plus number of neutrons. This is a very important equation. Make sure you know this, okay? People have a tendency to forget this year after year. Mass equals number of protons plus number of neutrons. So, if you know the mass number and the number of protons, you can figure out the number of neutrons. I'm going to show you in a minute, but you can find the mass on the periodic table. You also can find the number of protons on the periodic table. How? Well, because that comes from the atomic number. So if you know the mass, which you can get off the periodic table, and you know the atomic number, you can figure out the number of neutrons. So let's find the atomic mass, or the mass number, on the periodic table. So we're going to go back to our handy-dandy key again. Remember, always start with the key. So the average atomic mass, which is, we'll talk about average later, but it's in AMU. I'm not going to talk about right now why this is an average. Well, I sort of will. Okay, stop. Back up, Miss Moore. All right, here we go. Let's look at hydrogen again. It's got an atomic number of 1 and an atomic mass of 1.01. The reason for that is something called isotopes. The reason is 1.01, because think about it. If the atomic mass is the number of protons plus the number of neutrons, you can't have part of a proton or a neutron. So you would think that the mass of hydrogen would be exactly 1. But there's something called isotopes. For now, that's all I'm going to tell you. We're going to get to isotopes shortly. So what I want you to do for now is the atomic mass, round it to the nearest whole number. Okay, so we're going to say 1.01. The closest whole number is 1. So let's think about this. We have a mass of 1. Oh, let's remember that mass equals protons plus neutrons, right? So if we have a mass of 1 and we have 1 proton because of the atomic number, how many neutrons do we have? We have no neutrons. Okay, so hydrogen basically has no neutrons. But what if we look at magnesium? Magnesium has a mass of 24.31. So 0.31 is below 0.5, so we're going to round down to 24. It has 12 protons. So how many neutrons do we have? 12. Hopefully that makes sense. Okay. The mass number can also be written with the element symbol, just like we did the atomic number. So there's 2 ways this time, though. The first way is to say C12. Okay, with 12 being the mass number. Okay, it's the mass of that carbon. I could have a different carbon that was C13. This is still carbon, but it has a different mass number. Okay? Atoms need to have the same atomic number, but because of something called isotopes, they can have a different mass number. Atoms of the same type. Okay, so the next way to write it, here's what we had before. We've got the element symbol, we have the atomic number. Then we could put the mass number up here. Okay, so in this whole thing, this right here, and make sure you write this down because that's important, is called the nuclear symbol. The reason it's called a nuclear symbol is because it's showing what's going on in the nucleus. Because the top number is the mass number, which is the number of protons plus neutrons. The bottom number is the atomic number, which is the number of protons. And protons and neutrons are all in the nucleus, thus the nuclear symbol. All right. What we're going to do next is we're going to practice using your periodic table to figure out the number of protons, neutrons, electrons, stuff like that. All right, let's try this. So our first practice problem is nitrogen. And we're going to use the periodic table to find the atomic number. So that's a bad color, Miss Moore. Try that again. We're going to use the periodic table to find the atomic number and the atomic mass. And once we know that, we can figure out the number of protons, neutrons, and electrons. So I'm going to go to this periodic table here, and we are looking for nitrogen, which is there. Its atomic number is 7, so I'll fill that in. Atomic number is 7. And its atomic mass is 14.01, which we're going to round to the nearest whole number, which in this case is 14. Okay. So now that we know the atomic number, what do we know about the atomic number? Okay, we know that the atomic number equals the number of protons. Okay, so I can put 7 here. I also know that the number of protons equals the number of electrons. So because I know the atomic number, I know the number of protons and I know the number of electrons. So now I just need to figure out the number of neutrons. How do I do that? Well, I know, hopefully I remember this, that mass equals the number of protons plus the number of neutrons. The mass is 14. The number of protons is 7. So I just now need to figure out the number of neutrons. So figure out the number of neutrons. If I subtract 7 from both sides, I get, I didn't leave myself very much room, but I'll move it over here. So we end up with 7 equals the number of neutrons. So our number of neutrons is 7. Let's try one more. We've got carbon 13. Remember, what does this 13 represent? Do you remember? Let's go back way up here. That in this case the 12, but the 13 can be the mass number. So we know the atomic mass is 13. We didn't look at the periodic table for that, but we do need to look at the periodic table for the atomic number. And it's right here. It's 6. You will also notice that here it says carbon has a mass of 12. But because of isotopes, which we're going to get to later, the carbon we're talking about does not have a mass of 12. It has a mass of 13. Okay, so this is, let's write that down so you don't forget. This is the mass of this carbon. Okay, and I did all that talking, so the atomic number again right there is 6. All right, so if we know the atomic number, hopefully we know the number of protons and we know the number of electrons. And we know the mass. Mass equals protons plus neutrons. Mass for this particular carbon is 13. Protons is 6. And we need to try to figure out the number of neutrons. So we'll subtract 6 from both sides, giving us a 7. So this carbon has 7 neutrons. We're almost done here, but I want to go back and write the nuclear symbol for a few of these. So let's go back and remind ourselves what a nuclear symbol is. So the nuclear symbol has the atom symbol, and then to the left of that, as a superscript, it has the mass number, and to the left, as a subscript, it has the atomic number. So let's write the atomic symbol. Okay, I'm going to erase a little bit of this here. Maybe I'll erase all of it. Give myself a little bit more room. So the nuclear symbol for nitrogen. So we know nitrogen is N. I can look on the periodic table here. Nitrogen, the atomic symbol is N. And then the atomic mass, it's right there, is going to be 14. And the atomic number is 7. Let's try it for the next atom. What do we have else? Oh, we have sodium. All right, let's see. The atomic symbol for sodium is Na. So we'll write that. And then you try to finish it before me. What goes on the top? The mass. And on the bottom goes the atomic number. And let's try carbon-13. The symbol for carbon is C. And the mass of this particular carbon is 13, and the mass is written on the top. And the atomic number is written on the bottom. All right, folks, that's it for today. Have a good one.